now x equals -1. This time now it does not, we don't get anything we don't understand. We actually do get -2/3. That means when x is approaching -1 for this function right here, it will actually get close to this guy. So this is now the limit. Even though we said that x is not -1, we plug in anyway, and then when you plug in anyway, you get that number. In fact, that's the number where this guy will really approach. So that is the target value. The target value is actually -2/3 in this case. So if you use a calculator and the plug in x equals, let's say, if you plug in minus x equals -1.000, and then if you actually plug numbers such as this, then what will the function value be? The value of the function will be very, very close to -2/3. And as you plug a number which is closer to -1, it's going to be closer and closer, even closer to this point than the other numbers. So this is the target value. So the idea is, if you get 0/0, then somehow we have to change this form. And one way to change the form is by factoring the reducing. That's one way. But we have a few ways here, so this is not over yet. Okay? So that's the idea. So again, let's reinforce this idea. So I'm going to save this and then clear all this. Now what I'm going to do is, I'm going to scroll this down. Now scroll this down. We have example 4, 5, 6. Now what do you see? Yes. Now we see these lovely square roots and cube roots. And all of you like square roots and cube roots, don't you? All of you love square roots and cube roots, right? Especially cube roots. You better, expect cube roots. The cube roots and cubes might show up anytime because those are the exponents which I like this semester. Your instructor this semester likes cube roots and cubes and square roots too. Okay, so let's look at example 4. Example 4, what is this? Okay, limit of x minus 5 over x squared of x minus 1 minus 2. And now x is approaching 5. Okay, so what is this guy really approaching? Now, you don't know this answer yet. But now, let's say if you have a graphing calculator, then you can graph this guy. Or if you don't have a graphing calculator or you don't want to use a graph, you can still plug in x is equal to 5 points and then what? 0, 0, 0, 0, 0, 0, 0, 1. So what happens to this value when x equals 5.0000001? When you plug in x equals 5.0000001, will this function have some value? Yes, we will have some value. The question is, what is that value? That's what we want to figure out. Note that this expression when x equals 5 is undefined. So what happens when x is really close to 5? That's what we want to know. And that's the idea of this limit. But in this case, when you plug in 5, then oopsie, what happens? 0, 0 again. That means you can't plug in. You have to change the form. So in this case, what do you do? In this case, when you have a square root, then now this is the second technique. In this case, there's nothing to factor. And so because these are not, the denominator it's not a polynomial, and the numerator is a linear polynomial, there's nothing to factor there. The factoring technique here doesn't apply. So in this case, what does that apply? In this case, you have square root. The square root conjugate applies it. So in this case, what do we do? We are now going to multiply, and then we are going to go this, the limit here, and then this right here, and then you know what? We are now going to multiply by its square root conjugate. You know what square root conjugate is? This is square root of x minus 1 minus 2. The square root conjugate is square root of x minus 1, and then plus 2. That is what we call the square root conjugate of the denominator. The square root conjugate of square root of x minus 1 minus 2. The square root conjugate of this guy is this guy. Is this one. They're not the same, but these are what I call the square root conjugates. They kind of pair up. And I'll talk about that, okay? And now the question is, okay, so that's what we'll do. So we'll let me hold on to that. We'll get to the answer to example 4. Now, let's look at number 5, example 5. Example 5, now we have a cube. What shall we do with this guy? For cube root, we also have to find the, in this case, when you plug it in, what do you get? We also get this one, we get this 0 over 0 again. How lovely. The numerator will be 0, that's clear, but the denominator will be 64 minus 48, and then minus 16. Oh, so we do get the 0 over 0. And so you may ask me, so what happens if you get like 0 over 3? What happens if you get 3 over 0? Well, anyway, you know what? Those questions will be answered soon. Okay, just hold on. So right now, 0 over 0. Okay, so now we have to multiply the conjugates again. But this time we now
After
have a
two?
rule. So what is
Why?
the cubic conjugate of square
What
root
appointment?
2? Square
What
root
kind of appointment?
minus 2.
Okay.
What is the square root conjugate of this guy?
You didn't say that.
Now, in this case, if you multiply these two out here, these two are what I call the conjugates. Square root conjugates. Okay? Square conjugates. So now, in example 5, now we got a two root. What is this? How shall we now? You cannot apply square root here. So in this case, now let me show you the conjugate of this cube of x minus 2. And I'm sure that some of you may like it. You know what? Probably most of you hate this. Okay? What is the conjugate of this guy? Let me show you. This is a scary guy now. The scary guy is over here. The cubic conjugate of this guy is going to be cube root of x squared plus 2 times the cube of x.
Yes.
And then plus 4. This guy right here. You know? The cubic conjugate of this guy right here is this guy. All of you love it, don't you?
Why is it plus 4 at the end?
Well, I will show you. Okay, just wait up, hold on a little bit. I will get there. I have a next slide for you already prepared. So now, the thing is, when you multiply these two, the thing is, this will become x minus 8. And so, what is this formula here? This is actually related to the formula which we have known so far already. Do you know what? One of the factoring formula, remember, is this: a minus b times. This is called the factoring formula for the difference of q. I don't know how much you remember, but this is something you must have seen. A squared plus ab, and then plus b squared. So does anybody know what a minus b times a squared plus ab plus b squared is? If you multiply all this,
It's in the bathroom.
can anybody tell what this is?
Under the
What
sink?
is a minus b times a squared plus ab plus b squared?
Why would it be anywhere else?
This is a cubed. And then what? Minus b cubed. Oh, that's what it is.
What's
So
wrong?
when you do that, then when you multiply that, when you multiply by this guy right here, then what happens is the cube roots, they go away. So now what I'm going to do is now go save, and I'm going to clear this. Now I have prepared the next file for you. Section of 0.0715A, example 456. So very next file, let me open this one. And actually, I did this last time. Okay, so to save time. So am I sharing the page here? Yes, I'm sharing the page. Share. Now let's look at this. So we now come to section 1.5a, same file, and now I'm going to look at example 456. And this is how the solution looks like. Okay, example 4. Example 4 is this. Okay, this when it is a 0 for 0
You can't see? Are you dizzy?
So in this case, what do you do? Well, you cannot factor. There's nothing to factor here. So now what do you do?
Here, here's your glasses. Oh, you got
So we do
them.
that. So we see the denominator right here. And so what is the conjugate of this guy? This is the one with the denominator. It doesn't matter where you see the denominator. So the numerator is the denominator. You have to
wear a mask and keep the window down.
Whatever square is expressed in the numerator of the denominator. In this case, this guy is the conjugate of this other one. So we multiply by this guy, not the multiply this one. So what is that? This is A minus B. Now note that when you multiply, you know what? Let me scroll this a little bit. Oops. You know what? Just clear this. Okay, you know what? Let me just scroll this one a little bit so that you can see the factoring formula. So when you multiply these two guys right here, then what is the pattern there? Oh, that's A minus B times A plus B. That's what I'm using this guy right here. A minus B times A plus B. Isn't that A squared minus B squared? Yeah, we know that. That's what we call the difference of squares. So when you apply that, we get A x minus 1 minus 4. And we get this. Now, here is a very important thing. Now, these two guys should you multiply. Should you multiply these two factors? Should you multiply these factors? And the answer is, the question there.
No, because x minus 5 cancels out with the denominator.
Right. Let me tell you this. You know what? The answer is a big no. That's it. Big no. If you multiply this out, you have to mess up the calculation. So when you compute the limits, you have to be very careful. When you multiply unnecessary things, you are to absolutely right. If you're not sure what you're doing, don't do it. Even adding and subtracting, you have to watch out. If you do the wrong thing at some point, then you are going to convert a 1-minute problem into a 10-minute problem. And many of you, it's not 10-minute problem, you will never get the answer. So that one tiny mistake is going to mess up the problem. So if you're not sure what you're doing, then don't do anything. Even multiplying or squaring, you have to watch out. And some of you will make that mistake. So doing anything, any calculation unnecessary, that will be a critical mistake. You will not be able to get the answer. So in this case, the numerator, we are not going to multiply. Do not multiply. It's a big no. Now, sometimes we do multiply. Now, the denominator, why do you multiply these two then? Well, the denominator, these two guys are conjugates. So there's a reason to multiply to make it simple. And when you do multiply, that's what you get right here. So when you have conjugates here, definitely you multiply. But it's not there. If they're not conjugates, you're not sure, then you don't multiply. Don't multiply what you don't understand. If you have a question, you don't know what to do, then don't do anything. Especially multiply, you must be very careful. So now we get that. And now, if you plug in x equals 5, you just still get 0 over 0. Now you get this, and now you do this is x minus 5 here. And then you get this. And now, let's plug in. When you now plug in x equals 5 here, and now you get this, the answer is 4. So this expression right here, as x is approaching 5, this expression, this argument of the limit, is actually bearing closer and closer and closer to 4. So close to 4. So when x is approaching 5, this guy is approaching 4, and we say that this is equal to 4. We say that's the language of limit. We say that the limit is 4. So, you know what, before you do all this calculation, what happens if you really want to, let's say you want to cheat? Well, this is not a public sheet. It's not this function, okay? Plug in x equals what? 5 points, and then 0, 0, 0, 0, 0, 1. Or you can use the graphing calculator or a regular calculator. And then when you actually plug in, you can see that when you plug in this number, the result will be very, very close to 4. Or maybe 3.99999 or 4.000001 or something. And you can see, I think the answer, the answer might be 4. But you are not, it's not conclusive. Who knows? Maybe the answer is 4.0001 or 4.1. You don't know. So in any case, you cannot use a graphing calculator, which can kind of, get a hint. Okay, that's if you want to do that. That's fine. Now let's look at example. Okay, so example 4, example 5. Example 5 here, we get this. Example 5, now we get this. This limit is a 0 was the unitary form. Okay, yeah. So 0 plus 0, we checked that already. So now what do you do? Now we have the denominator here. The denominator is what? Is x squared minus 6x minus 12, that one we want to factor. If that is the if you do that, then we do get x minus 8 times x equals 2. And when you plug in x equals 8, you get a 0. And therefore, we know that there is x minus 8. So this is the factoring is easy. And now the question is, what shall you numerator? Cube of x minus 2, we multiply by conjugate. The question is, how do you get that conjugate? The key is right here. Difference of cubes, right here. That's the cube right here. And in this case, the cube of x minus 2 is that xa minus b. So this is our a. So cube root of x minus 2. So that is our a. That is our b. And this guy is a minus 2. So we have a minus b. A minus 2. So we have this and we have a cube root. So what we want is we want to cube this thing. So this case, we are not going to use the difference cube formula. This is the formula number 2. So if you have stuff here, then you will be using this. Now you will be using the sum of cubes. And so if this is a minus b, then what is the other factor? B is will be corresponding to the a squared plus ab plus b. So to one down. And that will be this power. That's where the a squared plus ab or b times a plus b squared comes from. And so when you multiply all that, then that becomes a cubed minus b cubed. And then you get the rest of it. Now note that this guy right here, the cube conjugate should also be multiplied the denominator as well. But this guy, we don't touch, we don't do anything with this guy. And by the way, when you plug x to this guy, this is not 0. Anything which is not a 0 and not infinity, usually we don't touch. Any factor which is not a 0 and not infinity, do not touch. Don't do anything. Let me say this. Any factor which is not 0 and not infinity, non-infinity, or usually you have nothing yet, okay, but it's going to show up. Don't do anything. Don't touch. That's what we touch. Don't touch meaning don't manipulate. Don't try to add or multiply, don't do anything. Just leave it alone. Leave it alone. Anything which is not a 0 and not infinity, don't do anything. So here, what is this, what's going on here? So when you, in this case, note that x squared minus 6x minus 16, when you plug x with 8, is actually 0. It is a 0. So when those are which are 0, you have to do something. In that case, we factor. And the numerator is a cube root, and that's a 0 too. So what you do, if that is a 0, you have to do something. In this case, you multiply by a cube root conjugate. So the factors which are 0 and infinity, we have to work on. All the other factors which are not 0, not infinity, don't bother. Don't bother, don't touch, don't do anything. Okay, so now class, let's look at example 6. Example 6, what is it? Example 6 here. Okay, so you know what, let me, example, yeah, there we go. Example 6. Okay, so I'm going to now save this, and then I'll clear all this. Now let's do example 6. Example 6 is right here. Example 6. This limit is a 0 for good indeterminate formula. Okay, so what is this? It is going to be this right here, okay? So when you plug it in, you get 0 over 0. That's a problem. Now, we see a square in the numerator, we also see a square in the denominator. Now, what do we do in this case? Do you multiply the top and the bottom by the square conjugate of the numerator? Or do you multiply the square conjugate of the denominator? Do you multiply that to the numerator and the denominator? So, what do we do? It turns out that in this case, you cannot just multiply the conjugate of the numerator and the denominator to the top and the bottom. But you have to multiply both factors on both to both. So what that means is the square of 7x plus 7 minus x minus 2 is this guy right here. We multiply that to the top and the bottom. That's what we have to do. And then the square conjugate of the denominator is this. We multiply the top and the bottom over here. So you multiply this guy and this guy too. We multiply the conjugate, the square conjugate, the top and the bottom for both. That's what we get. Once again, when you plug in x squared 3, we get 0 for 0. You always have to verify this. And all the factors which are 0, we have to do something. We have to work on it. It's not over. Now, when we do right after we do that, now what do we do now? What do we multiply? Now for the numerator, these two we will multiply because they are constant. And then this last guy here, this guy don't touch. Don't touch this guy. And besides that, it's not a zero anymore. So that when x equals 3, that guy is not zero. So don't touch. Not a conjugate of anybody, and it is not zero. Now the denominator is different. Now denominator, we have this guy here, and then we want to multiply with this guy. Why? Because they're conjugates. So when you multiply the two square conjugates, it does get simplified. And so when you multiply the two conjugates, you do get x plus 1 minus 16. So once again, we are using the difference of squares. And then this guy right here is just leave it alone. And then 7 minus x minus 4 is minus, and the factor of that is we get minus times x minus 3. And then 5x plus 1 minus 16, that's 5x minus 5. Factor the 5, you get this guy right here. And then we get that. When you plug it in here at this stage, you still get 0 over 0. So you know that you cannot plug it in even at this stage. Now continue. Reduce x minus 3, we get this. And once you reduce x minus 3, now you can plug it in. When you plug it in, you get this. Now we get a nice number. We don't get a 0 over 0 more. We get minus 2 over 5. So that is now the final answer. Any questions?
I have a question for example 5 still.
Okay, what is your question?
I just was a little confused from how the numerator changed from the second part of it to x minus 8.
Okay, good question. So what I'm going to do is I'm going to do that. Let me pull this up here. We are using the formula difference of cubes. Sorry. So let me do this one. We're using this one right now. So this one is, this is the cube of x, that's like a. And then minus b. So what is the cube now? Why do you want to use the cube root conjugate? Because we see a cube root of x, and ultimately we want a cube. We want to cube cube of a and cube of x. We don't want to square that. If you square that, then we still get this x to 2/3 power, and we don't want 2/3 power. We want x, and that's to simplify. And therefore we'll use this one. So that's a minus b. And now what is the cube root conjugate of a minus b? That will be a squared. That will be a squared, and then plus, and then plus ab plus ab, and then plus b squared. So first is to understand why that cube root conjugate looks like that. And our a in this case is what? In our case, a is equal to cube of x, and b is 2. So what is a squared? A squared is cube root of x squared. And then what is ab? Ab is cube of x times 2. b is 2 in our case. And then what is plus b squared? B squared, b is 2 in our case, so b squared is 4. So we get that. Now, when you multiply all this, so what we get? The result is a cube minus b cubed. So in our case, now what is a cube minus b cubed? What is that? So just the numerator here. So what is our a cube minus b cubed? A cube minus b cubed is going to be cube root of x cubed, and then it's going to be minus 2 cubed. You know what?
That makes sense.
If you really multiply this out as a regular expression, you can multiply this times that, and all that, and then you can do all that, and if you do all that, you will get the same thing. But we have a nice formula here. And this
That makes
guy
sense.
shows this is now what? This is now what the x minus 8. And you have to get used to it. Now everybody here, these practice formulas and these kind of examples here, I want you to practice these kind of problems here, these kind of practice, until it becomes easy to you. Not until you understand. But until these formulas and these kind of calculus become easy to you, should be a piece of cake. You have to be very familiar. You have to be comfortable. You have to practice until the process is easy. Okay, so here, practice these calculations until what? Until these procedures become what? Become easy. Okay, is that clear? If you get it, then you know what's not going to work. You must practice until these procedure becomes easy to you. Is that clear? If you just get it once, not good enough. No, not good enough. You have to. This is the case for everything in math. You need to practice until it becomes easy. It becomes very comfortable. It should be like eating a cake. Okay, is that clear? Or eating whatever. Or what is it? Or whatever. Okay? But it should be easy to you. So that's what it is. When you look at it initially, you'll say, oh, what? You say, what? Yeah, that's what everybody says. What is that? Where is that coming from? And they all get mad at me, right? And many students, when they look at this for the first time, they do get mad at me, right? But once you understand what's going on, it's not too bad, okay? It's not that simple, but, this is something you have to know, okay? And by the way, right now it's 10:04. I'm sorry to say this, but today there is no break, all right? So no break. Is that okay? Because we have to move on here, okay? So we'll have to move on. So today, sorry, but no break. So if you need to go to break, why don't you just move on? And a lot of the solutions are actually written like this, so you have to take it in notes, right? And so that's that. So now I'm going to save it, and then I'll clear all this. So now, is that the end of the file? Yeah, that is the end of the file, and yeah, that's it. Okay, now what I'm going to do, I'm going to go back to the file again, section 7.15. Did you finish this now? Let me see. Oh yeah, section 7.5. We get. Let's look at this. One-sided limits. One-sided limits. Yeah, one-sided limits. We have what we call the one-sided limit. What is the one-sided limit? One-sided limit means it is approaching a number only from one side. This means x is approaching 0 from the plus side only, not going by 0 plus. So there's a difference between x is approaching 0 and x is approaching 0 plus. So in this case, what it is we get this. So let me now do this. Annotate. Can all of you see this file? Anyone see my file here? Yes, you can. So this is actually going to be what? 1 over 0 plus. What is 1 over 0 plus? 0 plus is a tiny positive number. So you have x here, and we have 1 over x. X is approaching 0 plus. Means that x is like, what happens when x equals 1? That's 1. What happens when x equals 0.1? 0.1. If x equals 0.1, what is 1 over x? Can you tell me? Can you tell me what 1 over x is when x equals 0.1? 10. You're right. What happens when x equals 0.001? That would be 10, which is. What happens if this x is, let's say, 10 to the minus 1,000? By the way, 10 to the minus 1,000. This will be my favorite number. This will be the number I will be using when I need a number which is tiny positive. So 10 to the minus 1,000 is a very tiny positive number, right? And so we want to find out what happens when x is approaching 0 plus. 0 from the plus side. Now when you approach 0, it's undefined, of course. So we have to know what happens until we get there. So when you plug in that 10 to the minus 1,000, now 1 over 10 to the 1,000, that will be 10 to the 1,000. Absolutely big number here. So now the final question. As x is approaching 0, what is going to happen to 1 over x? Now we'll be getting
infinity.
plus infinity, you're right. Not hard to see that. Now note that when we actually plug in 0, this is undefined. But this undefined right here, this is what we call the functional value. Let me just call this guy f of a. This infinity right here, this is what we mean by the limit value. This is the limit of whatever function we're dealing with. And then x is approaching some number. In this case, x is approaching 0 plus. So there's a difference here. This is known as the functional value. Plug in 0, you get the function value. It's undefined here. But when we let this x approach 0 from the plus side only, this will be plus in infinity. This is the limit value. Limit value versus the function value, they're not the same here. And we have to now distinguish this. And now when it says 0 plus, it only approaches from one side, from the positive side. Again, if we let x approach, let's say 0 plus 0, then that means this could mean x approaching 0 plus, or it could be x approaching 0 minus. So when you say x is approaching 0 plus, what does this exactly mean? This means that x is close to 0, very close to 0, and at the same time, x is actually what? Positive. So when you say x is approaching 0 plus, what do you mean by this? What that really means is x is basically very close to 0, but at the same time, x is positive. And this guy right here is very similar. This guy is the left limit. We call that left limit. X approaching 0 minus is called the left limit to 0. Because minus is the left side and plus is the right side. So x is approaching a 0 plus, we call that the right limit and the left limit. So we can also have like x approaching, in this case here, we have x approaching 2 plus. That means that x is approaching what? X is very close to 2 now. And x is what? Is bigger than 2. That's what this x approaching 2 plus. The topic here is one-sided limit. If we don't have a plus minus, what does that mean? That means they are two-sided limits. All the examples we have seen up to this point, they are two-sided limits. So plus or minus, we get the same limit. But now here, from now on, the plus and the minus will split. They have different limit values depending on which way we approach. So now this is now complete plus infinity. Now let's look at 0 minus here. What is that? That would be 0 or 1 over what? 1 over 0 over 0 over, not 0. It's actually going to be 1 over 0 minus. Now what is 1 over 0 minus? Can you tell what this is? What is 0 minus? What does 0 minus mean? X approaching 0 minus, so let me explain here. When you say x is approaching 0 minus, what does that mean? That means
Is it from negative infinity?
Right, it is. X approaching 0 minus means x is close to 0. At the same time, x is less than 0. So this is roughly what it means. And in mathematical notation, we say x is 0 approaching 0 from the minus side, 0 from the left side. In this case, this is going to be minus infinity, you're right. Now note that the plus side is infinity, minus side is infinity. Now this one now we cannot define this anymore. This is now a two-sided limit. But the two-sided limit x equals 0, that depends on the both one-side limits. But in this case, one side is infinity, the other side is minus infinity. Now you know what, there's inconsistency. So here we say the limit does not exist. The limit does not exist. Does not exist. By the way, in Calc 2, now this is also called divergence. This is language of Calculus 2. Divergence in Calculus 2 language. Calculus 2 language. Okay? For some reason, when you go to Calculus 2, they call this divergence. But in Calculus 1, for some reason, we don't use this term, but actually it's the same thing. Okay? So in this case, the final answer is the limit, you take the limit. So when you have a two-side limit here, what do? Then you have to split. But sometimes you split, sometimes you don't, so that's the tricky part. But in this case, the plus sign and the minus sign, they're different. By the way, when you actually graph that graph, so what happens when you actually graph that? When you graph y plus 1 of x, the graph looks like this. And then when you look at that, this graph, you get this. And so this is 0 right here. So this is y plus 1 of x. So what happens to the y value when x is approaching 0 from the plus side? From the plus side, you go this way, so it's going that way. So 0 is x is approaching 0 plus. Along the curve, note that along the curve, the points along the curve, when x is approaching 0 from the plus side, it's heading to plus infinity. That's what that guy means. So the right limit is plus infinity, but from the left side is x approaching 0, from the minus side it actually goes down. Oh, so there is a graphical meaning to all of these guys here. So it's going to plus infinity over here, and this is going to plus infinity and minus infinity down here.
Oh, are you sleeping?
If you get an example, let me give you another example. How about if you get an example like y plus 1 over x squared? This is one of the graphs which I showed you yesterday. This is what I call a volcano. Volcano, how does the graph look like? X squared, it actually goes up like this. In this case, if you actually have the limit, 1 over x squared, and x is approaching 0 from both sides, this is now a two-side limit. You know what this will be? This will be plus infinity. And no matter which way you approach from, either way you go to plus infinity anyway. Note that at 0 is undefined. So we don't consider the case when x equals 0. What we're interested in when x is close to 0. In this case, from either side, it is going to go up to close to infinity from both sides. So this will be plus infinity. But this guy right here does not exist. Why? Because the right limit, the left limit, they split. And then they get different answers here. So slightly, now things are getting a little more complicated. All right? So if you know the graph, you can actually see the answer. There's a closeness between the limit of the graph. Okay, so now let's see what happens to example 8. Example 8, now we get into absolute value. And all of you love absolute value, don't you? You love absolute value? Yes. Now, when you plug it in this x approaching 2 plus, we will also apply what? This is, by the way, this means x is bigger than 2. That means x is not 2. X must be bigger than 2 now. Now, in this case, when you plug in x equals 2, 2 plus is still 2, plug it in, or you get 0 over 0 form. This guy is 0 over 0 form. Cannot put it in. 2 plus is still 2. Therefore, we cannot plug it. We plug it in, we get 0 over 0. So this doesn't work. It's an indeterminate form. So now what do we do? This is now going to be the limit. Now this is what we do. This is x approaching what? 2 plus. What is this absolute value of x minus 2 going to be? That will be x minus 2. And then over x minus 2. You get this limit right here. So everything is sitting there. Now what did I do here? What I did was absolute value of x minus 2 will equal x minus 2. Why is that? Because x is bigger than 2. If x is bigger than 2, what can you say about x minus 2? X minus 2 is actually what? X minus 2 is actually bigger than 0. And if that x minus 2 is bigger than 0 and has an absolute value, what happens? Absolute x minus 2, or x minus 2 is actually bigger than 0, that just pops out. Because inside the absolute value is positive, so that pops out. And now we have no more absolute value. And now what is that guy going to be? And this guy will actually be equal to 1. The limit is 1 in this case. And you can actually confirm that through your graph as well. Now let me erase this. Eraser. Let me erase this forward. Now how about example 8 part B? What is that? Part B What is the part B? Part B is this, the limit. Again, this is also a 0 over 0 form. This time x is approaching 2 minus. X approaching 2 minus, what does that mean? Oh, 1 second. 2 minus. What that means is x is less than 2. And if x is less than 2, what do we know? So what we get is the x minus 2 is now less than 0. Oh, that's something inside that absolute value is actually less than 0. X absolute value of 2, absolute value x minus 2, but x minus is less than 0. So you know what that becomes? That becomes minus of x minus 2. That's what we get. Oops. And then over x minus 2. Oh, you see this? 2. And then now, x is approaching 2 minus. We can now reduce this guy. And when you reduce this guy, what happens? Oh, we are left with minus 1. That's what it is. You know what? We can do the graphing outside, but let me, how about the save? Let me save this. Oh, undo. I'm just going to erase this part right here. And then I'm going to graph this. Y is equal to absolute value of x minus 2 over x minus 3. If you graph this, do you know how the graph looks like? Let me show you how the graph looks like. You can always use that on your graphing calculator. So what is the graph of y is equal to x absolute value of x minus 2 over x minus 3? How does this graph of this guy look like? I don't know. Those of you who have never seen the graph of this kind, you might have to maybe graph it to understand exactly what's going on. Although graph is not required here. So what is this guy? The graph of this is going to be like this. 2. Open, and it's this. The graph of this guy right here is right here. And this guy is 1. This y value is negative 1. So what happens to the y value along the curve as x is approaching 1 or 2 from the plus side? So we approach this way. So these guys are approaching here. So even though when it comes to x equals y, x equals 2, it's empty, it's undefined. So we are not interested in plugging x equals 2. We don't want to know when x equals 2, but we want to know when x is getting close to 2. So as you can see, when x is getting close to 2, what happens? Is the y value is actually targeting 1. The y value is approaching 1. It's actually 1, 1, 1 is always 1. And so it's approaching 1.
You're not the computer.
That's why the answer is 1. So now if you let this x approach 2 from the minus side, then we actually come this way along the curve. And then what is the y value approaching? Y value is approaching minus 1. That's how the graph looks like. Okay, again, I can spend, I don't know, quite some time here. But again, you know what? This is the graph. This actually, well, it's kind of, it's kind of pre-calculus. Advanced pre-calculus, I should say. Okay, so that's that. So what I'm going to do is I'm going to now save this and clear all this. And if I scroll this down, we have example 9, example 10. You know what? Example 9 and 10, let me skip them. And now let's just look at example 11. As a piecewise defined function. Is a piecewise defined function. Let me see. What is this? 7.5a. Example 1. You know what? Now why don't I go to the web decimals here? I'll show you how to graph that. Right now I'm trying to do example 11. And so example 11, the graph is going to be like this. Now this one, let me see. Hopefully I can type this quickly here. How do I type this in? X is less than 2, X is less than 1. X is less than 1, and then what? And then colon, what is X squared? X squared plus 1. And I'm going to teach you how to draw these piecewise defined functions. This is a piecewise function, and then comma, and then what is X is greater than 1. And then what is it? The minus X, and then plus 5. And then we get this. Yeah, this is very good. You know what? Let me. So right now we are doing example 11, and now so you know what? How do I? Where's my what is it? How do I annotate? How do I annotate this? Wait a minute. I don't know how to annotate. Here? Okay, I see. Oh, there we go. Annotate. There we go. So this is basically our example 11. This is y is equal to this. X squared plus 1. When x is less than 1. And this is minus x and this plus 5. When oh yeah, it's becoming messy. So I'm trying to refer here, and it's becoming more messy. It's greater than 1. And so when you graph this is actually how to type. Okay, I'm teaching you how to use decimal here and typing this. Now, what is unclear? One thing is actually unclear. Now, when you actually use decimal, so that means you need to kind of look like this. But one thing is not precise here, and that is when x is approaching 1 from the positive side, it should be this guy right here. So this must be star is star, and this must be opened up. And this part is not clear of the graphing calculator. I think most calculators are like this. They don't put a circle there. Okay? So this is the part which you have to be careful. And this one is the y value 2, and this guy the y value 4, as you can see. So now, what is the question here? We have the question. What is the limit? The one side limit. So what we have is part A. Part A is this. Part A is the limit. The limit. X is approaching what? X is approaching by 1 from the plus side. By 1 from the plus side. And this is f of x. Yeah, and by the way, this is our f of x. So I should have looked at f of x here, but anyway, I will y is f of x. When you graph this into calculator or type in this, I think you have to write y. You know what? I don't know what happens if you put f of x here. I think you can use the letter x there. But anyway, if you type in this way, then it will work. If you put it a or that, it kind of works too. But you can try. Okay? So this is the example for typing in a piecewise defined function. So what is this? So what is the function value as x is approaching 1 from the plus side? Now if you look at the graph here, what do you think the answer is? Can you figure out the answer from the graph? Anybody? Can you tell me what the answer is if I look at the graph? So you get the answer 4 when you look at the graph. Now, if you want to do this algebraically without the graph, then you get this. Then this is what you would do, limit, and then now x is approaching 1 plus, and that 1 plus means x is actually bigger than 1. So when x is bigger than 1, which expression are we going to use for the function? Well, we use that function. We use that function right there. Because this is x is greater than 1. Right now we have x is bigger than 1. So we have it's part of this. So this will be minus x and then plus 5. It's a piecewise function. Now, plug in x equals 1. X approaching 1 plus means x approaching 1. So plugging 1 minus 1 plus 5 equals 4. There. That's the answer right there. So now what is the left limit? The limit x approaching 1 minus f of x. What is this? Now, what is the answer to this function? What is the answer to this limit? If I look at the graph, can you tell me?
2.
2. That's right. When x is approaching along the curve, when x is approaching 1 from the left side, that means the points are heading this way. And the points are heading this way. And where are these points targeting? Where is it heading to? They are actually heading to this point right here. And at that point, y value is 2. The y value is heading to 2. Even though at 2 it's undefined, actually the point is over here, but that's not what we're asking. That's the function value. The left limit is 2. The right limit is 4. The function value is also 4. In this case, now let's do this algebraically. So if we did not have the graph, what do you do? Then this is what it is. Limit x is approaching 1 minus, and x approaching 1 minus, what does that mean? That means x is less than 1. And if x is less than 1, then which branch do we use here? X is less than 1, and x is less than 1 here. So we have x squared and then plus 1. So now, when x is approaching 1, what do you get? 1 squared plus 1, you get 2. There we go, that's 2. And then now we have one more left here. Now part C is the function value. What is f of 1? What is f of 1? Can you tell what f of 1 is? What is f of 1? Huh?
What you said the f of 1. The f of 1 would be 2 or 4.
No. It's 4.
Oh, it is.
With f of 1, you just look at the absolute value. You look at the function there. It's a piecewise function. Note that x equals 1. Which branch will take care of x equals 1? The bottom branch. Why? Because it says x is what? X is
Greater than or equal to.
right here. Equal 1 is not over here. X equals 1 can only be included in one place. So it's the bottom branch, second branch, branch number 2. And so, when you evaluate f of 1, we have to use the second branch because it's x is equal to 1 right here. So plug in 1 right here. X equals 1, and then we get 4. So the function value is 4. The right limit is also 4, but the left limit is 2. So this is the concept of the right limit, left limit. So I'm going to now save this, and then I'm going to clear this. And then, you know what? You have many more examples there. So what I'm going to do, I'm going to go back to the file. And am I sharing this page?
We can see it. Yes.
Yes, I'm back here. Okay, so now I'm here. And by the way, we have this. Now, you know what? Example 12, this is what we call, what I call the great integer function. But you know what? Let me skip this one out because I don't have that much time. Okay? So let me skip this one. So I'm going to skip that one. And then the bottom of example 14 and 13 is just a practice of what we did before. Example 13 and example 13 and 14, why don't you do this? These two are covered. So what I'm would like to say is example 12, I'm not going to cover this one. So not on this one. Let me say that. So this one here, this right here, G is the great integer function. Greatest integer function will not be on midterm 1. Midterm 2, maybe. Okay, so I don't know. By the way, we call it the great integer. Programmers call this function, int x is called the integer function. But in math, we call this a great integer function. Names are a little bit different. Int x. It's called integer function. Integer function. Okay, anyway, anyway.
You're not supposed to be up there.
Infinity symbol on my keyboard, so in plus infinity. Now let's look at example 5. Example 5, what is this? Oh, this is going to be 3 over 0 plus. Oh yeah, that is the same guy. This guy is also plus infinity. This guy will go higher and higher. Now let's look at example 6. Example 6, almost the same as example 5, but this guy's now a two-sided limit. X are pushing 0, and then does not specify plus or minus. Now, if it's 0 plus, it's going to plus infinity. 0 minus, it goes to minus infinity. In this case, we have no choice, so we have to now split. We split this guy. Limit, x is opening what? Now we have to calculate 0 plus. We have 3 over x. And then the other branch, 2 branches. The other branch, the bottom branch, second branch is limit, x approaching 0 minus. If you don't know exactly what's going on both sides, and or they're different, then you have to split this. So now what is this? Oh, this one is now going to be plus infinity, where this guy is going to be minus infinity. Therefore, the original limit, what can you say about this guy? We can say that the limit does not exist. Because the right limit is infinity minus the left limit is minus infinity. Okay, so now let's look at example 7. Example 7, oh, this one is just infinity